Okay, so here's our second lecture out of Chapter 3, Basics of Networking. And I'm going to start off this particular talk today with just kind of a general diagram here of what it might look like when we go to open up a website or something using our computer. And to us it appears like there's just a direct connection from our computer to the web server, but we all know that there's lots of different routes that we can take and lots of different interfaces that need to connect here. So this picture shows this is actually a symbol for routers, and if you look the red line through here, you connect to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different routers to get to the web server. You might think of that as those routers could be maybe in the same building, or they could be all over the world. All right, and the point is most of it is just we're oblivious to it. It's not important. Right, some vocabulary here when we start talking about communication. One of the most common communication categories is synchronous communication, when both the sender and the receiver are active at the same time. And a typical example of this would be a telephone call. Both the sender and the receiver are actively participating at the same time, versus an asynchronous communication where they could potentially take place at different times. So for instance, you might be on an online class here and you send me an email at midnight on Monday night, and I respond to you at 9 a.m. the next morning. Alright, so both of us aren't online, but we still have a successful communication. So make sure you're able to distinguish between synchronous communications versus asynchronous communications. Other communication types that we should differentiate is the idea of a broadcast versus a point-to-point communication. So when I'm on a telephone, for instance, there's a sender and a receiver. Okay, so it's a one-on-one communication, and that's the characteristic of a point-to-point. Versus a broadcast, some examples of broadcasts: I turn on the radio. It's a one-way communication, and really it's a one-to-many communication. So one radio station broadcasts to perhaps thousands of individuals. Okay, so broadcast communication versus a point-to-point communication, and in a synchronous communication versus an asynchronous communication. So universal communication media, the internet, doesn't really care if it's synchronous, asynchronous, if it's point-to-point or a broadcast. It's just that the internet's the fabric, it's the network that connects all that stuff together. Alright, so we look at point-to-point asynchronous, we could have point-to-point synchronous, so we can combine those two ideas, and there's some examples you can consider for that. A multicast might be differs from a broadcast, where it's a communication from one to selected users, where a broadcast is out to everybody. Alright, and a nice kind of modern update of broadcast technologies from radio to television are things like web pages. Right, so we have a server, and I think we all know that definition of servers. We heard about servers. Okay, they're centralized, they store information, and they have many clients that connect to it. Some examples: we have web servers that's use the HTTP protocol, and that's generally how we serve up web pages. We have file servers that we might use on a local area network in an office, or even here in a college setting, where we can store our files, and they use a little different protocol. Versus mail servers, where they interconnect to other mail servers, and again, it's a totally different server protocol. So a client is the one that connects to a server, and a server provides what you might think of as a service. So if I'm on a web server, I click on a web link, then my computer or my client requests from the web server the page, and then the web server responds by sending me data back that involves pictures and HTML, text, and all that. All right. The other interesting thing is, once the web server provides me that particular file or whatever I'm looking at, it disconnects. Okay, so we have a series of we have a relationship where I'll ask for something, it serves it up to me, and then in a lot of cases we're done. All right, so that's the end of our relationship at that point. All right, so here's a diagram, shows your network, which we saw the fabric. Here we look at this as more of a logical model that we don't really care about all the routers in there, but the client computer is able to somehow connect with the server, and across that network go ahead and receive those files. Alright. So client-server interaction, some other characteristics. Relationships are brief between a client and a server, so usually a server can serve multiple clients, alright, all at the same time. So you think of a place like Google, and just fathom how many hits a day they get and how many happen simultaneously. Well, Google's able to service those. Google has another, just kind of as a side note here, Google actually has more than one server, as you might imagine, that services the general population. And they use a protocol, a round robin type of protocol, where it'll hit the first user that comes in, it's first come first serve. First user will go to one server, second user to second server, third user to third server, and then it will just go ahead and go back to the first server. So when you get really busy servers, and we'll see an example of that, that's why I mentioned that when we start looking at DNS, when you start getting busy servers like Google, they have they use the concept of redundancy, where they have multiple servers with the same information on it. Right? And one client computer can also ask for service from many servers. Okay, and this is pretty typical. If you look at the left-hand part of this diagram, here's my client, and I don't know where you guys are, but I'm really a big multitasker anymore. I bring up my web browser, and several years ago they came up with tab browsing. So I might be on those various, I might add 6, 7, 8, 10 tabs across my browser, and they're all looking at different places. They're all requesting information from different servers. All right. The converse of that is true as well. As a server, you might be hosting a number of different clients from all over the place. All right. So let's dig a little deeper how all this is put together. An analogy I'm going to use here is telephone book. All right. So at one point, and I guess things have changed a little bit, but the old telephone book, if you went to call somebody, you had to have that book, and you looked up that book, and you look up somebody's name on it, and from their name in a column right next to it would tell it the telephone number, and that's the way we make calls. Now things have changed a little bit if I use my telephone analogy, because I think most of us store all of our phone numbers in our cell phone, and that kind of acts as our address book, and we don't really have to look anything up anymore. We just look for the person's name. Okay? Think of the same concept with IP networks and computer addresses. So every computer, just like a phone, needs to have its own address. And IP addresses are interesting because they have 4 parts to them. All right, so they're actually known as octets. Okay, so they have 4 numbers, and those numbers can range from 0 to 255. You wonder why it's an odd number. It's because it's the binary system. Each one of these octets can, an octet can hold 8 bits. Okay, and you can do a little math there, figure out what that means. So we have a 4-part IP address, and those are really convenient because that's the way computers think and the way computers work. But for us as humans, that doesn't work so well. Not that we can't use an IP address to connect to a web server, but it's much more convenient for us to have a host name. So for instance, when I want to connect with the University of Montana web server, I go to www.umt.edu, and I don't even know in most cases what the IP address is. Okay, an IP address, I've been at the university for a lot of years now. I know it begins with 150, the second octet is 131, and I couldn't tell you what the last 2 numbers are there. All right, so that's so computer addresses use host names, and think of these as human readable names. The example here, excuse me, your textbook authors from the University of Washington, and here's an example of his computer in the computer science department at the University of Washington, which is an educational institution. All right, so you look at his example on that bottom line there, and we're going to tear that apart a little more, but it makes sense. Right? There's actually a thought process into that hierarchy. All right. So here's just kind of maybe an example network with a bunch of different IP addresses, and the computers not only have IP addresses, but they also have friendly names, which are also known as host names. All right. So we start talking about, let me go back to this for a second. We have a collection of computers like this, and they have something in common. We usually call that a domain. All right, so here's maybe one domain or subdomain at the University of Washington. So we start talking about domains. By definition, it's a related group of network computers. Domains, another characteristic is they're organized in a hierarchy. So we have what's known as top-level domains, and this is important vocabulary here. A top-level domain, be sure you're able to give an example of a top-level domain. So most common are .coms. But we also have .nets, .orgs are typically utilized for nonprofits, .edus are colleges and universities. You'll find some K-12 schools in a .us domain. The .ca domain is for Canada. The .nz is for New Zealand. .uk, United Kingdom. So we also have, with domains, we also can assign countries to domains. All right, so that's a top-level domain. Looking at this example here, we can take this apart. So this domain name, indicated in the top line, is spiff.cs.washington.edu. So top level here, you almost read these backwards, is an edu or educational institution. The second part of it, or the second level domain, is Washington, which is of course the University of Washington. And then the third level domain, or the subdomain, is known as CS, which is an abbreviation for computer science. And then the last part of this is actually the name of a computer. So stiff is the name of the computer, and if you think of that computer as having an IP address, here is its user-friendly name. So maybe it belongs to Professor Spiff in the computer science department at the University of Washington, which is an educational institution. Okay, hierarchy. It's another way to look at a hierarchy here. In this particular diagram, it shows it as a cloud. So in the edu domain, you got the University of Washington domain, you got the Princeton University domain. Somewhere in there, you got the University of Montana domain. And inside each of those domains, you have subdomains. So here at the University of Montana, we might have the Missoula College subdomain, which we do. It's called CTE. We have the, maybe the School of Business, the College of Arts and Sciences, etc. Okay, so we have the top level domain .edu, the second level domain, which is the University of Montana, or the Montana domain, and then we have the subdomains that might be made up of the various colleges. And you can see how we can use that hierarchy to organize our computers. Here's another way to kind of display graphically a hierarchy, is with something that I think you see in the business world, an organizational chart. And we refer to the very top of the whole domain structure on the internet as the root. And we use a single period to represent the root. You might think on, if you work with any type of file management tools, the root is typically like the root of my file system. If I'm on a Windows machine, it's a backslash. If I'm on a Linux machine, a Unix machine, and I believe an Apple machine as well, we have just the opposite representation. Rather than a backslash, we have a /. Okay, so that's the top of my directory structure, or the top of my file hierarchy. All right, with this particular one here, we're on the internet, and rather than a / or backslash, we use a period, and then we have a series of top-level domains. All right, and then we have our second level domains, where we're at the University of Washington, Princeton University, University of Montana, and then everything underneath that is you could have one or more subdomains. And there's no limit to this. If you think about how a hierarchy works like this, it's a tree shape, but it can continue to grow down on it. All right, a little different than our initial. Here's the cloud way of viewing the internet domain hierarchy. And then here's the more organizational chart method for viewing it. All right, the other thing we have on the internet that are really, really important are DNS servers. Okay, and DNS is, and again, it's a service, so DNS provides translation, and what it does with a lookup is it translates between a friendly name, okay, also known as an FQDN, okay, to an IP address. All right, so if I put in a friendly name, I put in www.umt.edu, what DNS does for me is it acts as the telephone book. It looks up that particular domain name and correlates it to an IP address. We also call that a forward translation. And then it responds to the computer to go to this particular IP address to find it. All right. So those are really, that's the basis of how the internet is put together. All right. And so you got my little lecture here of it. Please read this in your textbook. And I think if you're able to grasp these kind of simple concepts that I've presented here in these 10 or so minutes, I think you have a really good idea of how the internet works.